Hello everyone, I hope you all are doing well. Today we will be solving the next question of the Blind 75 series. It will be the ninth question of the series. The name of the question is threesome. This is the question, guys. But before starting with the question, I have a suggestion for you that if you have not solved the two-sum problem, I will highly recommend you or advise you to solve the two-sum problem first, because this problem is an extension of two-sum problem. We will be using the same concepts and techniques that we used to solve the two-sum problem. So, if you have the knowledge of those concepts and techniques, you will be able to understand the modifications that we are applying in those concepts and technique in order to solve this problem. So you will be able to better understand the solutions of this problem if you have already solved the two-sum problem. So it is highly recommended to solve the two-sum problem first and then come to this problem if you have not solved the two-sum problem. The problem statement is you are given an integer array nums and you need to return all the triplets such that I is not equal to j, I is not equal to k, and j is not equal to k, and nums of I plus nums of j plus nums of k is equals to 0. Notice that the solution set must not contain duplicate triplets. Guys, the question states that you will be given an array as an input, and in that array you have to pick up those triplets which are the sum of whose elements is equal to 0. Now what does this triplet is? A triplet is nothing but a group of three elements. So if you are given an array, you can pick any three elements from that array and you can group them together to form a triplet. So in an array there could be multiple triplets. So out of all the triplets you have to pick those triplets sum of whose elements is equal to 0, and you have to simply put all those triplets together and return them as an answer. So while you are picking the elements in the triplets, there are some conditions that need to be satisfied. So there are two conditions that are given over here which need to be satisfied while we are picking the elements in the triplet. So let's understand these conditions first. The first condition is I should not be equal to j, I should not be equal to k, and j should not be equal to k. So here I, j, and k are representing the indices of those elements which we are picking up in the triplet. So this condition simply states that I cannot pick one element twice in the triplet. For example, guys, if this is an array which has elements as 1, 2, 3, 4, 5, 6, and in the 0th index, suppose we have element as 1. So if I have selected the element of 0th index, so the first element of the triplet will be 1. So this condition simply states that if I have selected the element of a particular index in a triplet, so I cannot select that element again in the triplet. So if I have selected the element of the 0th index, so now the second and third element should be from some different indices. So this condition simply states that all the three elements that we are picking in the uh, triplet should be from the different indices. I cannot pick the element of one index twice or thrice in a triplet. And the second condition is the solution set must not contain duplicate triplets. So uh, this condition signifies that the order of elements in the triplets does not matter. So what does this mean? So suppose we have a triplet which has the elements as 1, 2, and 3. So this condition states that the order of element in the triplet doesn't matter, uh, even if the order is different and the elements in both the triplets are same. So those two triplets will not be considered as a distinct. Those two triplets will be considered as a same. So here you can see that in the first triplet, the the order of elements is 1, 2, and 3. So if in the another triplet I take the element as 1, 3, and 2, so although the order in which the elements are occurring is different, but ultimately the elements are same. So we have one here, we have one in the another triplet, we have two here, we have two in the another triplet also. So we have three here, 3 also exist in the another triplet. So if ultimately all the elements of the triplet are same, so these two triplets will not be considered as a distinct triplets. These two triplets will be considered as a same triplet. So we have to, keep this thing in our mind that the elements of the triplet should be different. We cannot just change the order of the elements in order to form the different triplet. So this is the second condition. So now guys, you know the conditions that need to be satisfied in order to form the triplet, and you know what a triplet is. Now we have to think of the solution of this problem. So the very first approach that comes to our mind is, as we need to uh, check the triplets whose sum is 0. So what I can do is I can just check all the possible triplets that I can form in this array, and uh, the triplets which will give me sum as 0, I will simply include those triplets in my answer. So this is the very basic approach, or the brute force approach that comes in our mind while we just think about the solution of this problem. So now the question comes, how we can generate all the triplets that exist in this array. So for doing that, we will be using the 3 pointers, guys. uh, I will fix one pointer. So let's suppose we have to pick 3 elements in a triplet, right? So let's assume that the index of the first element will be I, and the index of the second element will be j, and the index of the third element that we will pick in the triplet will be k. Okay, so we have to find all the possible values of this I, j, and k in this given array. So for doing that, what we will do, initially we will fix I and j. Okay, so we will fix I at the first index, and we will fix j as at the second index, and we will fix k at the third index. Now what we will do, uh, at first I will just keep this I and this j as static, and I will try to find all the possible values of k for this particular I and j. So if I is -1, j is 0, and k is 1. So like what I will do, I will just fix the value of I and j, and for this I and j I will try to find out all the possible values of k. So ultimately I have fixed first 2 elements of the triplet, and for these 2 elements I am trying to find out all the possible value which the third element can take. So initially k is at 1, so the triplet that will be formed will be -1, 0, 1, and the another possible value for this particular value of I and j that k can take is this. So I will just keep on increasing k to the next index till I reach to the last index to form the different triplet. You can see here we are forming the triplet. Initially the triplet that was formed was -1, 0, 1, and next time uh, I and j remained at their positions, but k moved to the next index. So we got a new triplet that was -1, 0, 2. Again, when I will move k to the next index, the triplet that I will get will be -1, 0, -1. Again, when I will move k to the next index, the triplet that we will form will be -1, 0, -4. So in this way, for this particular value of I and j, I have checked out all the possible values of k, and I have formed all the triplets in which the first element is -1 and the second element is 0. Now, what I will do, now I will move the second element. For this first and this second element, I have checked out all the possible values of the third element. Now what I will do, I will just move this second element to the next index. Okay, so initially I took j from here. Now I will just move j to the next index. Now I is -1, j is 1. So similarly, we will start k from the next index, and for this I and this j, I will try out all the possible values which the k can take. So in this way, by using 3 nested loops, we will be able to generate all the triplets of this given array. Now guys, as you have seen the two conditions that we were given over here, that we have the very first condition is uh, we have to always take the elements from the different indices. That is, I cannot take the element of one index twice or thrice in a triplet. So like we do not have to worry about that condition here, because we are moving our I, j and k pointers in such a way that we will always be considering the distinct indices. So we have to think about the second condition only. The second condition is we always have to take the unique triplets, right? So guys, if you see in this array, so I want a triplet whose sum is 0. So if I select this -1, 0 and 1, so if I select this triplet, so the triplet will be -1, 0 and 1, and you can see that the sum of this triplet is 0. Okay, again next time, uh, if I just put my I pointer at the 0, j pointer at the 1, and k pointer at the -1, the triplet that I will get will be 0, 1 and -1. So guys, the sum of the first triplet is 0, and sum of this triplet is also 0. But are these two triplets distinct? Uh, these two triplets are not distinct, guys, because what I told you, that order of elements in the triplet does not matter. If the values of the elements in the triplet is same, so those two triplets will not be considered as the different triplets. These two will be considered as the same triplet. You can see here -1 exists in both the triplets, 0 exists in both the triplets, 1 exists in both the triplets. So ultimately, both the triplets contain the same elements. So we cannot consider these two triplets as the different triplets. We have to consider these two as the same. So we will have to store the triplets in such a way that I should be able to compare uh, the triplets whether they are equal or not. So when I will just get any triplet, I will store it in such a way that I should be able to compare with the next triplet that comes, whether this particular triplet is equal to that particular triplet or not. So for doing that, what I will do, I will always try to the store the elements of the triplets in a particular order. So I can store the element of a triplet in ascending or a descending order. For example, if I store the elements of the first triplet in the ascending order, so the elements will remain in the same order because it is already in the elements are already in the ascending order. So the order of elements will be -1, 0 and 1. But uh, in the second triplet, the elements the first element is 0, second element is 1, and third element is -1. So if I will arrange the elements of this triplet in the ascending order, the triplet that we will get is -1, 0 and 1. Now we can see that both the triplets are actually same. So if I will always store the elements of the triplet in the ascending order, then I will be easily able to compare the two triplets whether they are same or not. So in this way, I will be able to generate all the unique triplets uh, from of this given array, which gives the sum as 0. So guys, this is the brute force approach that we will follow to find the solution of this problem. Now we will just write the code for this particular approach, and then we will analyze the time and space complexity of this approach. Let's store the size of this array in this variable n. Now I have to try out the different possible values of I, j and k. So for that I will be using the three nested loops. J was always starting after I, so I will start j from I plus 1, and k will always start from j plus 1. And every time when I will pick the element of this ith, jth and kth index from the array, I will get a triplet. So I will check if this is a valid triplet or not. So if the sum of elements of this triplet is 0, then it will be a valid triplet. So if the sum of the elements of this triplet is 0, so it means it is a valid triplet. So what I will do, I will store the elements of this triplet in a vector, and guys, as I told you, we have to always store the unique triplets. So I will always store the elements of the triplets in the ascending order, so that I can identify it later whether the triplet I am getting is unique or not. So I will simply arrange the elements of this triplet in the ascending order. So for doing that, I can simply sort this temporary vector in which I have stored the elements of the triplet. Okay, so this is a triplet that I have got. Now we have to store these triplets, and as I always need the unique triplet, so what I can do, I can declare a set over here. So this set will store the vectors, and we will name this as S. So I will simply store this uh, triplet that I have got in a set, so that again if the similar triplet comes, so the set will simply ignore that, because the property of set is that the set will always store the unique values. So I will store this in the set, and once the iterations for this I, J and K is over, so I will have all the unique triplets that sums up to the 0 in the given set. So I will just put those, I will take the triplets from this set, and I will store those triplets in this vector of vector of integer, as I have to return these triplets in the vector of vector. So let's declare a vector of vector. Let's name this as answer. So I will put all the triplets from this set to this answer vector, and at last we will simply return this answer. Guys, the sample test case have passed. Let's submit this solution. Okay guys, you can see that out of 312 test cases, 308 got passed, and rest is giving the time limit exceeded error. So let's first analyze the time complexity of this particular approach. Then we'll think of optimizing this. So you can see here we are using three nested loops. Uh, we can say that in the worst case, these three loops will run near about n times. The loop j and k will not exactly run n times, but let's assume in the worst case they will go up to n times. So time complexity for these three nested loops will be big O of n cube. And you can see here we are using the set data structure to store the triplets. So the insertion and deletion operation for the set data structure is of logarithmic order. So time complexity for this particular approach will be n cube into log of number of unique triplets, because in the worst case, the maximum number of elements that we will store in the set data structure will be equal to the number of unique triplets. So the time complexity will be n cube into log of number of unique triplets. Let's talk about the space complexity. So the extra space that we are using over here is this set data structure and this vector of vector. So both of these data structures are used for the purpose of storing the unique triplets. So the space complexity will be twice of number of unique triplets. So guys, you saw that this solution gave us TLE, because the time complexity of this particular solution is very high. So we have to think of the another solution which is better than this. So let's go to the another approach to solve this problem. You saw in the above approach, we were using three nested loops because of which the time complexity was becoming the order of n cube. So in this approach, we will try to avoid one of the three loops that we were using in the previous approach. For doing that, we will use a little bit of maths. So we know that sum of all the three elements that we are taking in the triplets would be 0. So nums of I plus nums of j plus nums of k should be equal to 0. So if I keep nums of j on the one side and send nums of I and nums of k on the other side, the relation that I will get is nums of j should be equal to negative of nums of I plus nums of k. So if I fix the value of I and k, then the value of j should be negative of nums of I plus nums of k. Then only the triplet that I'm considering is valid. Otherwise, it will not be valid. Okay, so let's understand this approach with little bit of dry run. So what I will do, I will fix two pointers uh, among the three pointers that I have. As I told you, I will be having three pointers I, J, and K. This the I is the I is the index of the first element that I am considering in the triplet. J is the index of second, and K is the index of third element. So what I will do, I will just fix I and kth pointer, and I will just take a hash set which will store all the possible values of K for this particular I and K. So if I if I add them up, -1 plus 0, so the sum that it will be -1, and if I do the negative of this, the sum will become plus 1. So I will check if I have +1 in the hash set. I don't have +1, so what I will do, I will simply move k to the next index. So before moving to the next index, I will include 0 in the hash set. Now if I add them up, so the sum I will get will be -1 plus 1, that is 0, and if I do negative of 0, it will remain 0 only. And I will check, do I have 0 in the hash set? And yes, you can see that I have 0 in the hash set. So it means I have got a valid triplet, that is -1, 0, and -1. Again, I will change the value of k, so I will move k to the next index, but before moving to the next index, I will just include this one in the hash set. So I will again check, uh, -1 plus 2, that is 1, and if I do the negative of 1, that is -1. So -1 does not exist in the hash set, so I will move k to the next index. uh, but before moving k, I will just include this 2 in the hash set. So guys, what I am actually doing, you can see that for like I am fixing the first and third element, and for this first and third element I am storing all the possible values that the second element can take in the hash set. So and I'm simply checking for this particular first and third element, do I have a valid second element? So if I'm getting a valid second element, I am just including that triplet in the answer. So again, when my when I is here and k is here, the sum will be -1 plus -1, that is -2. If I do negative of, if I do minus of -2, that is +2, and you can see that I have +2 in the head set. So I have again got a valid triplet, that is -1, 2, 2, and -1. So in this way, you know, by just keeping just considering two values of I and k and storing the values of j in the hash set, I will be able to check up all the triplets in the given array. And guys, as you know the condition that that I always have to consider the unique triplet, so I will use the same technique that I used in the previous approach. I will use a set data structure to store the unique triplets. So let's write the code for this particular approach. Then we will analyze the time complexity of this approach. Okay guys, now let's write the code for the second approach. So let's keep the size of this array in the variable n, and as we need a hash set to store all the possible values of j, so I will take unordered set that will store the integer values, and let's call this as hash. So this is to store possible values of nums of j, and I will need a set data structure to store the unique triplets. So I will define set of vector of integers. Let's name this as s. Now let's start two loops to consider all the possible values of I and k. And if the value, as I told you, if the value of uh, if the value of I and k is fixed, then nums of j should be equal to negative of nums of I plus nums of k. Then only it will be a valid triplet. So the target that I want is negative of nums of I plus nums of k, and I will simply check if this particular target is present in the hash set or not. So if this condition got satisfied, it means I have got a valid triplet. So I will just store this in the temporary vector as I was doing in the previous approach. I will sort them up, and I will insert this in the set. Sorry, it will be not nums of j, it will be target rather. Okay, so before moving to the next index, I will just include this kth element in the hash set. And guys, you uh, when I will move to the next index, I will have to again consider different values of j. So I will just clear this hash so that I don't consider this value for the next iteration of I. So when the iteration for I and k is over, I will I will have stored all the possible values in the set data structure. So let's uh, declare a vector of vector, because I have to return a vector of vector, and I will put all the elements that I have stored in the set to this vector of vector. And at last I will just return this. Oh, sorry, we have to return the answer. Okay, you can see that the sample test cases are getting passed. Let's submit this solution. Again, guys, you can see that one test case is still not passed, so we have to still optimize the solution. So let's analyze the time complexity of this solution. So we are using two nested loops. Again, in the worst case, the time complexity can go up to big of n square because of these two nested loops. And I am using this hash set. So like uh, the insertion and deletion operation for the unordered set is of constant time. Uh, in the worst case, it can go up to big of n, but in the normal scenarios, it will be constant. So we will not consider the time complexity for this particular hash set that we are using. So we will consider the time complexity for this particular set that we are using for storing the unique elements. So the time complexity for this particular approach will be uh, n square into log of number of unique triplets. N square is because of these two nested loops I am using, and as I am using this set data structure to store the unique triplets, so logarithmic of number of unique triplets for uh, insertion operation in this set data structure. The space complexity will be twice into number of unique triplets plus big O of n. So as you can see in the code, I am using this set data structure and this vector of vector to store the unique triplets. So twice into number of unique triplets plus I am also using this unordered set. So it will take like at max the maximum number of elements that will be stored in this hash set will be near about n. So it will not be n exactly, it will be always less than n, but let's take that as an n. So the uh, space complexity for this particular solution will be twice into number of unique triplets for vector of vector n set plus big O of n for the unordered set. So guys, you saw that this solution also gave us TLE error. So we have to optimize it more. We have to think of a better solution again so that our solution gets accepted. So let's move to the last approach. That will be the third approach, and it will be the optimized approach. So here we will be using the concept of two pointers that we use in the two sum problem. So that is why initially I recommended you to just go through the two sum problem first, because we will be using the modification of two pointers approach that we use to solve the two sum problem. So initially what I will do, I will just sort the array that is given to me as an input, and after doing that what I will do, I will fix out of three pointers. What I will do, I will fix one pointer, that is I will fix the ith pointer, and for if I fix this ith pointer, and then I will try to find out the value of j and k that should be there in order to find the valid triplet. So what I will do, I will fix I here, j next just after I, and k at the end, and I will try to move this J and K in the right direction to get the valid triplet. So how I will do this? Let's understand this with the help of dry run. So I will just do the sum of all these three elements. So the sum will be minus 2 plus 2, that is minus 4 plus 2, which is minus 2. So minus 2 is less than 0. So the sum is lesser than 0. So I need to increase the sum. So as I told you that ith pointer is fixed, I cannot move the ith pointer. So to increase the sum, I have to move either jth pointer or the kth pointer. So k is already the at the largest possible value. I cannot move k further. What I can do is I can move j further to get the greater value, but again, as there are duplicates, j still remains in the minus 2, so I will move j again. So the moment when I move j to here, the triplet that I will get will be minus 2 0 plus 2. And if I just sum up the elements of this triplet, it will be equal to 0. So it means I have got a valid triplet, that is minus 2 0 and plus 2. So in this way, by moving jth and kth pointer for this particular value of I have got a valid triplet. Again, as I have considered this triplet, I will move j ahead and k in the backward direction so that I consider the different triplet. But guys, you have to keep this case of duplicates in mind. So this is a kind of edge case that if there are duplicates, so j and k still remains same. So it may happen that you again consider the triplet as minus 2 0 and 2. So it is actually the same triplet, so I do not have to consider it again. So what I will do, I will move j pointer till I get a new value. So in this way, I will be able to check the it. I will be able to get the distinct triplets every time. And as you saw in the previous approaches, we were using the set data structure to store the unique triplets. But here we don't use. Here we will not require the set data structure because we will move our I and j pointers in such a way that we will our both the conditions that indexes should be unique and triplets should be unique will always be satisfied. So let's write down the code for this particular problem. Then we will analyze the time complexity for this particular approach. So initially I have to sort the given array. Then I will start my ith pointer. Let's declare j over here, sorry, n over here. Okay, so if this is I, you can as you have seen in the approach, uh, j will start just after I and k will start from the end always. So j will be I plus 1 and k will always start from last index. And I will use the two pointers approach that we used in the two sum problem. While j is less than k, while j does not cross k, I have to find the sum of these three elements, that is nums of I plus nums of j plus nums of k, and I will check if sum is less than 0, then I have to increase the sum. So for doing that, I will move the jth pointer, and if sum is greater than 0, then I have to decrease the sum. That I will do by decreasing the kth pointer. And if these two conditions are not satisfied, so it means I have got a valid triplet. If I am coming to this condition, so it means that I have got a valid triplet. So what I will do, I will declare a vector of vector over here to store all the uh, valid triplets. So what I will do, I will create, sorry, I will just push this vector in my answer, nums of I, nums of j and nums of k. Then I have considered this triplet now. Next time I want to consider a different triplet, so I will just move j ahead and k in the backward direction. So guys, as I told you again, it may happen that even after moving uh, j and k, because of duplicates, j and k can still remain in the same value. So you have to uh, keep the check of duplicates in mind. So uh, while array of if array of j is still equal to array of, sorry, if nums of j is still equal to nums of j minus 1, so I will move j ahead again. Similarly, I will do the same thing for the k. If nums of k is still equal to nums of k plus 1 after decreasing the value of k, so I will again move k by one step. So guys, it may happen that it will go out of bound, so just keep the check of the above condition that j should be less than k and this condition. Again guys, this may happen for I also, that I am again considering the same value of I, so I will keep the check for this also, that if nums of I is equals to nums of I minus 1, so I will just continue. I will not do anything in this iteration. I will consider the next value of I. So it may as I am doing I minus 1 here, so it may go out of bound, so I will just keep a check that I should be greater than 0 for this particular condition. Okay, so when finally the iteration is over, I will have the answer stored in my this vector of vector, so I will just return this. Okay, let's run this now. Okay guys, you can see the sample test cases have passed. Hopefully this time our solution will get accepted. Let's submit this solution. And guys, it gets accepted finally. So this is all for today's video. We will meet in the next video. Bye bye, take care.